Okay, welcome to the last video of the review for Chapter 8. So I'm going to take a look at number 5 first. Find the coordinates of the y-intercept and x-intercept of y equals x squared minus 2x minus 15. So y-intercept is pretty easy. That goes back to the graphing problem. If I substituted 0 in for each of these x's, 0 squared minus 2 times 0 minus 15, that would just give me this last term, negative 15. So that's my y-intercept, 0, negative 15. My x-intercepts come from my factors and then using the zero product property. So I'm going to do factoring here. What times what is x squared? X times x. What multiplies to negative 15 but adds to negative 2 would be negative 5 and 3, positive 3. And if I set each of them equal to 0, I'll figure out what my x-intercepts are. So what makes this parenthesis 0, what minus 5 is 0 is positive 5. What plus 3 is 0 is negative 3. So my two x-intercepts are 5, 0 and negative 3, 0. Okay, now looking at some review topics here. So for number 6, we're going to talk about writing the explicit equation for each of these sequences below. Remember, arithmetic and geometric have different equations, so I need to consider that when I'm looking at the sequence. So I'm looking at this sequence and thinking about what is the pattern. So how did I go from 100 to 10, 10 to 1, 1 to 0.1? So in order to go from 100 to 10, and then 10 to 1, I'm definitely not subtracting the same number, so I must be dividing. So if I'm dividing or multiplying, the way I could get my multiplier is I take this second term and divide it by the previous. So if I do 10 divided by 100, I get 0.1. You may be like, well, Mr. K, didn't we just divide by 10 each time? And that's fine. We did do divided by 10. That is the pattern, but it's not going to help us in our equation. We need the multiplier versus what we're actually dividing by in the equation. So we are multiplying by 0.1. So my equation is y equals my starting value. This is tricky because you may say, well, it's 100. But remember, the starting value is the 0 term, so we have to go backwards. In order to go backwards, instead of multiplying by 0.1 to go this way, we're going to do the opposite, and we're going to divide by 0.1. So 100 divided by 0.1 would give us 1,000. So my starting value, my 0 term, is 1,000. My multiplier is 0.1, and I don't know what my exponent is. I'm putting that as my variable, and I just needed to write that equation. Now for this next one here, I'm again looking at this, thinking about what the pattern is, and this one again is going down, and I'm thinking, is it subtraction? How do I go from 0 to negative 50? Sorry, this should be a comma. So it looks like I could subtract 50 to get there, and then if I subtract 50 again, I do get negative 100, so this is actually an arithmetic sequence. So when you're writing arithmetic sequences, you put your sequence generator, your growth rate, your pattern, whatever you want to call it, in front of your variable, and we're using our y equals mx plus b here. And then my 0 term is going to go at the end. Remember, that's not 0. We need to go backwards to get the 0 term. This is the first term. So if we go backwards, instead of subtracting 50, I'm going to add 50. 0 plus 50 is positive 50. So there is my equation. Y equals negative 50x plus 50. And for these types of problems, if you ever want to figure out if you have the right equation, all you need to do is substitute a term number into the x and see if you get that actual term in your sequence. So if I plugged in 1 here, I would get negative 50 times 1, which is negative 50, plus 50 is 0. That does work out. And then if I checked it over here with any of these, it would work out as well. Okay, last topic here. Rewriting radicals and fractional exponents, just changing forms, it's actually pretty easy. So if I am trying to change this radical into a fractional exponent, so if I think about this part, this is called the index of the radical. The index of the radical becomes the denominator of the fractional exponent. And whatever this number is being raised to becomes the numerator of that fractional exponent. So I don't see an exponent here, so it must be being raised to the first power. Same thing in number 8. I'm trying to rewrite this using fractional exponents. So I'm going to put my x, and I know that the index of the radical is the denominator of the fractional exponent. And since x is being raised to the third power, that is the numerator of my fractional exponent. And now I could go backwards and do the same thing. I know the denominator of the fractional exponent is the index of the radical. And I know that my y must be raised to the third power if that's the numerator of the fractional exponent. And then same thing in number 10. 7 is the denominator of the fractional exponent, so that must be the index of the radical. And x must have been raised to the second power if that's the numerator of the fractional exponent. So pretty easy, just switching back and forth between fractional exponents and radical form.